Hello again. We're back again. So last about an hour ago now, just over. Obviously last stream, we did past paper. We did June 2018. The paper one, a non-calculator. So the aim of this, I guess, in a way, it's a follow-up, but I'm gonna do a little of an ad hoc a little revision session of some topics. I think topics which are key for specifically non-calculator. Um, but there's three topics I want to go over in this little session. I think it'll be like 15 minutes. I don't know. And that is multiplying and dividing. That is mentally. So that is long multiplication and the bus stop method, which allows us to multiply and divide big numbers and decimals. The next we're going to go over exact trig values. Oh, and I've got a little tip or a trick, I guess, to help you remember them. So you need to remember all the trig ratios for these following angles. And standard form. Okay, cool. Okay, first of all, let's start with multiplying. So I guess this is just going to show the method of long multiplication. So I'm going to go back to, actually, I'll come up with a question myself first of all. So for example, let's start, nice, actually no, no, let's do one example, a simple one to show the method. So for example, 27 times 102. Okay, so with long multiplication, there are many methods you can use. Grid method. I think there's a Chinese method. God knows, there's many methods, but I think the one that I guess the most common one is long multiplication. Uh, so how you want to lay this out is put the big number first, and then the small number here, and then what you're going to want to do is for the first digit times in by each digit up here. So 7 times 2 is 14. And then, like with addition, carry the 1. 7 times 0 is 0, add the 1. And 7 times 1 is 7. And then when you're on the next digit, every digit before it, you want to put 0. And then we start the same process again. 2 times 2 is 4. 2 times 0 is 0. And 1 times 2 is 2. And then you want to add these up. So 4 times add 0 is 0. 1 add 4 is 5. 7 and 0 is 7 and 2, and there we go. So the answer to this should be 2754. And you can check that with a calculator. Yes, cool. Oh, hang on. I need more space. Hang on. Do, 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 do. Yeah, there we are. Okay. look at some questions. Okay, so these are the type of questions you'll get in the paper. Let's go over another one then. Let's go back. So now we'll look at example decimals. So let's look at 75.4 times, say, 12.6. So the idea with this is, first of all, when you use long multiplication, you're going to need to use it with integers, whole numbers. These are in decimals. So what you can do is you could say this is the same. So 754 times 126 times by 10. So kind of use standard form here. So how many decimal points have we moved from 754 to 75.4? Wow, you've gone back by 1, so it's -1. As likewise with here, how many decimals you moved back from 126? 1 point there. So it's going to be another -1, so it's going to be -2. So whatever answer we get here, we're then going to move 2 decimal points back. So first of all, we need to compute this. So 754 times 126. So 6 times 4 is 24. 4 carry the 2. 6 times 5 is 30. And 32, add 2, 32. 2 carry the 3. Then you have 6 times 7, which is 42. Add the 3, 45. So that's 5, carry the 4 over to 4. And then again, we have a 2 here. Let's get rid of these. So add a 0 here because the 6 is now a placeholder. So 0 here. And then 2 times 4, which is 8. 2 times 5, which is 10. 0 carry the 1. 2 times 7 is 14. And 1, 15. And then carry the 1. Lovely. And then we have 1. So now there's 2 zeros here because there's 2 numbers before it, 2 digits. So we're going to 0, 0. And then we're going to do 1 times 4, which is 4. 1 times 5, 5. 1 times 7, 7. And then we can add all these entries together, these 3 numbers. 4, 0, 0, 4. 2, 8, that's 10. 0, carry the 1. 5, 4, 1, 10. Again, carry the 1. 4, 5, 5, that is 14. Carry the other one, 15. That's 1, carry the 5. 1, 7, 1, 9. So the answer to this is going to be 95.004, but we have times 10 to the -2. So that means we have to move 2 decimal points. So here and then here. So it's going to actually be 950.04. If you are not comfortable with standard form or stuff like this, which coincidentally we will be doing later in a little bit, you could just say this again, split it into you could phrase it like this. So the original multiplication, you could say 754 times 126. Again, always convert it into whole numbers. That's the key idea of this. But you could say then move to how many places have we moved here? 1 to the left, and this one is also 1 to the left. 126, 12.6. You move decimal 1 to the left here. Same with here. You move 1 decimal to the left, so you move 2 points to the left. So, and then you compute the multiplication as usual, and then you say, well, we move 2 points to the left in this answer here, which we've done here. That is exactly the same thing as this 10 to the -2. But this is just a more accurate way of saying it. But you can phrase it like this if you want to. As long as you get the final answer, you should be fine. Um, uh, that's really it. I'll do one more, but with a decimal like this. So 0.026 times 31.8. Okay, pretty rough one. So again, we're going to say 26, that's the whole number, times 318. But how many points have we moved? Okay, let's use it the worded one to make it easier this time. So notice here, we have moved the decimal point from 26 to 0.26. 1, 1, 2, 3 to the left. And likewise with here, we moved 1 to the left. So 3 to the left and another 1 to the left is now 4 to the left. So whatever our answer is, and also if you did it in, you should be getting this as well. If you did it in standard form, um, but we have to move 4 decimal points to the left after our answer because this to get from 26 to this, you move 3 points, and here to here you move 1 point. Okay, and if you do like this, you should always be moving to the left. Um, if you're multiplying, you should always, when you do this, it should always be the left. So yeah, there should be no confusion there, hopefully. But that's how you can phrase it if you want to. But now let's do this. So 318 times the 26. Again, like 8 times 6 is that is 48, I believe. 8 carry the 4. 6 times 1 is 1 at 4, 0, 10, 0, and then we'll carry the 1. 3 times 6 is 18, and 1, 19, carry the 1. Lovely jubbly. Same with the 2. Remember, there's a placeholder now. So 2 times 8 is 16. 6 carry the 1. 2 times 1 is 2, and for 1, 3. And 2 times 3 is 6. And then add them together. Get rid of this 1 here. 8 times 8, 0, 8. 0, 6, 6. 9, 3, 12. 2 carry the 1. 6, 1. And a 1 is 8. And that's it. So the answer to this is 8,268. But we're moving 4 points to the left. So it's going to be 1, 2, 3. And then another point here. So we add 0.8268. Okay. And let me just double check that. Oh, yes, that's the answer. So that's how you would approach decimals like that. And that is going to be this is the type of question you'd probably see on the first question or so. And even if there isn't a direct multiplication question, it's also a very, very good tool to have in general with non-calculator. If there's a number quite, that's a bit hard to work out, it's also good safety to do it mentally with this method in case you miscount or whatever. So that's the multiplication division now. Again, it's similar sort of thing, but now I'm just dividing. I'm going to jump to a decimal example again. So again, it's the same sort of principle. Convert to numbers and then do the method, and then reconvert to a decimal. So let's do 41.6 divided by 7. I don't know what this will work out to. Let me check this before. Let's see if it's does this give a good result? Nope. Uh, let's try this. Okay, there we go. Let's divide by 8. There we go. This should give a nice result. Okay, with division, uh, I think the best way to do this is to write this as a fraction. Remember, with fractions, say a over b, it is always exactly the same as saying a divided by b and vice versa. If we can say a divided by b, it's same as a over b. That's what a fraction is. It's just a division, just a bit fancier. And that's what the symbol means as well, this divide sign. It's actually a fraction here with two numbers, which are dots, as a placeholder. So that's where that comes from. But I'd say write as a fraction and you'll see why, especially in other examples. So write it 41.6 over 8. And what you want to do now is, it's like with equivalent fractions, you want to get rid of decimals. So the way to do this is to times by 10. If you times by 10, you move the decimal point 1 to the right. So now it goes to 416 over 80 times top and bottom by the same. And actually now this is the whole number which we want. And the beauty with this is that you don't need to adjust the decimal point after. This is the exact division we want. So the way we lay this out is with bus stop method. Uh, put the right number here, 80, and then 416. Usually the bigger numbers in the front, and the 80s outside. Because usually you want to do bigger number divided by smaller, but really it's the right one, the right number, the one after the division, the denominator outside, and the top number in the middle. Okay. I'm gonna move this up here a little bit. There we go. So the way with this is, the way we do this is you look at the right number and you could do it digit by digit, and you want to see how many times this number goes into the digit. So 80 doesn't go into 4, so that's going to be 0. But then what about 8? And then you do 41. What's 80? What's 80? How many 80s are going to 41? So, in other words, you're doing 41 over 80. Well, it doesn't go into it, does it? That'll still be 0. So then you consider this whole number. How many 80s going to 416? If you are struggling, you can list multiples of 80. So 80, 160, 240, 320, 400. And then if you add another 80, you'll go over. So 1, 2, 3, 4, 5. And actually, there's a remainder of 16. So what you can say then is, whatever the remainder is, uh, add 16 on, and like carrying, essentially, carry the 16. And then you add a 0 in when there's a decimal point. Add the same decimal there. And then you do 80 over 160, which actually is 2. Bang on. With no remainder, so that's the final answer. Um, so yeah, so the answer then is, read the top number on top, and it's a 5.2. Okay. If you didn't want to do, I really strongly do recommend converting to a fraction first to see where the decimals are. But if not, again, you could say in powers of 10. So this is 40 what 460, 416, sorry, times by 10 to the minus 1, because we moved one decimal point to the left, divided by 8. And well, 8's a whole number, so we don't have to do anything. Uh, hmm. Actually, no, it's a bit messy, actually. It's not, yeah, I really don't recommend doing this. Just ignore what I said. I don't recommend going through that route. It's very messy. Um, but yeah, I strongly recommend this. Really, right as a fraction. So there you can see clearly how you should change the decimal points. Okay. I wonder, is there what example is on here? Yeah, my examples cover all this pretty much. Let's do this one here. 18.6 divided by 0.8. So that's an example. 18.6 divided by 0.8. Cool. Again, I like what convert as a fraction. 18.6 over 0.8. Both are decimals this time. If you times by 10 on either side, if you times them by 10, you move the point to the right by 1. So that's going to be the same as 186 times that by 10. And with equivalent fractions, you have to do the same to both sides. So times this by 10. That moves the point to 8. And actually, they're both whole numbers now, which is great. You could actually spot some cancellations here. You could simplify the fraction if you're confident, but let's go through the formal process. So again, the denominator is in front, 186. And so, yeah, so then do it digit by digit. How many 8's go into 1? None, because 8's bigger. Then 18. So 8 goes into 18 twice. So it's 16 with remainder 2. So bring the 2 on here. So now we've got 26. So then we get 8. And how many 8's go into 26? Uh, well, uh, well, it's 24. 8, 16, 24. So that's 3 with a remainder of 2, right? 24 to 26 remainder 2. Add a decimal point. How many 8's going to 20? Well, 8, 16 with remainder 4. So that's going to be 2. Remainder 4. Then how many 8's going to 40? Well, that should be exactly 5 times. So actually, our answer here should be, if you read off this, 23.25. Yes, bang on. Okay, lovely, and that's basically that's what it all boils down to. Those are what's expected. Like that's the level of arithmetic they'll ask you to do in like the first question. So I'd strongly predict it will come up either multiplication or division. They will expect you at some point to do some sort of mental maths here. It's really not too complicated. I don't think don't throw away easy marks. It really isn't that bad. They can't overcomplicate this. It's the same every time. It really is. It'll be like the first few questions in the paper, and it'll be for both tiers as well, higher and foundations. It apply to everyone. This is a crucial skill to learn, and it's not too long to learn. It's not too complicated either. Anyway, so that's a mental arithmetic. A quick rundown on that. I then want to run down over exact trig values, and I do have a way of learning it. So trig values, what do I mean by that? So that is literally evaluating stuff like sine 60 degrees, cos 45 degrees, tan 30 degrees, and so on. Basically, it's any input of the trig function sine, cos, tan over, well, yeah. And actually, it turns out you do need to learn what all these three values, sine, cos, tan. When you plug in 0, 30, 45, 60, and 90. And actually, you can use this to work out other values as well if you look at the graph. So, as an example, let's look at the sine graph. If you know, so, say this is 60, yeah, you should also know, well, it's symmetrical about this point here, about this hump here, 90. So actually, distance between 60 and 90 is 30. So 120 will be the same as sine 60. So if you look at the symmetry of the graphs or the graph properties, if you can spot other values as well. So if you know what sine 60 is, which you should, you can also know what sine 220 is, and stuff like that. Likewise, if you know, let's draw the graph again. If you know 30, which should be down here, 30 degrees, you should know what 150 degrees is as a result. Because 90, the distance is 60 between 90 and 30. And then the other 60 gets to 150. So either side is the same because it's symmetrical about the humps. So if you know what sine 30 is, that's exactly the same as sine 150 if you just read off the graph. But yeah, that's just a quick rundown of that. So let's look at the values themselves then. Because I strongly suspect, and again, it's kind of 3 marks. It really is once you learn them, and it's not. I don't think it's too bad, but I don't know. So look at all these then. So the way, and it turns out there are exact values, not decimals, but exact numbers that these come to. So let's have a look at them. So how do I approach this? Well, actually, some people learn triangles. I can't remember what they are. I don't use triangles. If you're fine with triangles, that's cool. But I'm going to show a hand. It's called the hand method, I like to call it. I'm going to draw a really, really weird hand. Uh, God, how am I going to do this? Let's draw a hand. Oh, God. There you go. Like the weirdest hand ever. If your hand looks like that, God, go to the doctors. Okay, so yeah, obviously each hand has 5 fingers, and each finger is going to correspond to a position. So uh, I'm going to call it the zero. The zero. How do I want to? How should I label it? No, let's call it one. The first finger, the second finger, the third finger, the fourth finger, and the fifth finger. You don't really need to label it. But we'll leave it there. So the way this method works is, uh, if you use sine, let's first of all look at the values of sine. Okay, so I'm not happy with this labeling. I'm gonna get rid of it actually. Uh, Instead, what I'm going to say is I'm going to label these as degrees. So 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90. Okay, a really weird zero. So sine of an angle theta. Um, how are you going to read this off? What the method is of an angle theta. What you're going to do is you're going to root what finger you on, root of the finger, and you'll see this makes sense in a minute. Root finger over 2, always over 2. So what do I mean by that? So, uh, The finger is essentially the position you're at. So this is kind of why I like to label the position. So if you remember, if you start at 0, you've not moved anywhere. So it's 0th position. So sine of 0 is going to be root 0. Because it's almost like the 0th position. It's not that we don't start at 1, we start at 0. So it's going to be root 0 over 2, which is just 0. And that should make sense because if, obviously the graph, obviously it starts uh, at 0. So that checks out for the first value. The first finger is 0. And then what you're going to do is for each angle labeled here, you're going to start moving anti-clockwise, right, to get sine. All the different values that you need to know. And you're going to use the finger position to work this out. So sine 30, you moved one finger, so first position. So it's going to be root 1 over 2. So substituting what the finger number is, how many fingers you've moved. So root 1 over 2, well, root 1's just 1, so it's a half. And that's the exact value. Then we're going to do sine 45. And again, now from 0 for the first finger, 0, we've moved one finger, two fingers. So so it's going to be root 2 over 2. You can't simplify that anymore. That's the exact value. It's a third. Okay. Sine 60. Again, from 0, moving this way. You're going to go 1, 2, 3. So 3 fingers, move 3 fingers. So it's root 3 over 2. And then sine 90. Again, from here, you're going to move 1, 2, 3, 4 fingers. Which actually, root 4 is 2, because it's 2 squared equals 4, right? 2 over 2, and that simplifies again to just 1. So sine of 90, 1. And those are all the values you need to know for sine. Okay. Now, actually, because it's very, very, very similar. So let's do cos 0. But actually, you know, when we said we move this way, so move the 0 finger that way, we're going to go the opposite way this time and start with from 90 and move clockwise around the other side of the finger. So if you want cos 0, again, it's the same formula. It's the exact same formula, but obviously the finger positions flip. So if you want cos 0, we start here now. Again, we've moved 1, 2, 3, 4 fingers. So cos 0 is going to be root 4 over 2, which we've seen here goes down to 1. And then cos 30 is, again, you're going to move from here to 30. 1, 2, 3. So it's going to be root 3 over 2. And we can't do anything more with that. Cos 45 is, again, you're going to move 1, 2 fingers from the starting one. Root 2 over 2. And then cos 30 is going to be, again, we did cos 30, didn't we? Cos 60, sorry. Cos 60 will be one finger moved, so root 1 over 2, which is just a half. And then cos 90, well, cos 90, we haven't moved. So it's going to be root 0 over 2, which is just 0. And again, that makes sense with the graph, because the cos graph will look like this. So it starts at 1, at 0 this time, and then at 90, it reaches 0. And actually, if you want, you can use this to help you learn the graphs if you want as well, to know where the key intersections are. But yeah, that's how we work out cos and sine. Essentially using the fingers to guide to, where they are. So if you label your finger like this and then just move across to work out the angle you want, label it like so. And the good thing with this is you don't have to memorize weird triangles and their values and different triangles. I much prefer this. It's just one hand. You can even put your hand on the paper, and you can label it. You can visualize it. You just need to know how to use it a little bit. But I think it's quite simple. I don't know. Maybe I've explained it the best. I do apologise, but this is just a rough sketch of how to learn them. It's how I learn it, even now. Like God know how long, however long doing maths for. Still remember it now without calculator. These values because of this method here. Okay. Now I did say you also need to know tan. Now tan is very special because instead well, you do need to use the hand, but if tan essentially what you need to do, and it's a bit more work, you need to find what the sine value is and divide it by the cos value. So let me give a demonstration at tan 0. So let's do these values, tan 0. Wow, that's going to be, you need to know sine of 0 over cos 0. And if you're struggling with finding these values, use the finger, work out what the sine is and the causes, and then divide them. This will always be true as well. Always. In A level, you look at this as well. But remember, divide the sine by the cos to get tan. So sine 0 over cos 0, well, we've seen that cos sine 0 is 0, and cos of 0 is 1. So 0 over 1, which is 0. So tan of 0 is 0. Now let's do tan 30. Now this is sine 30 over cos 30. Um, and if you wanted a quick sketch of why this is true, let me just very briefly outline it. Say hypotenuse of 1, and this is theta. Now you should know SOHCAHTOA. Uh, so the opposite, so you know sine theta is opposite. Now over hypotenuse, now the hypotenuse is 1. So therefore you just times by 1 sine theta is simply the opposite. Okay. Very similarly, the cos, the adjacent, cos theta is adjacent over hypotenuse, which is also 1, and then times by 1. So cos theta is simply the adjacent here. Now, if we use the definition of tan, SOHCAHTOA, so tan theta is opposite over adjacent. But opposite is sine theta, and adjacent is just cos theta. So there you go, we get this formula here. You don't need to learn that. That helps. You just learn if you want to. It's up to you. But that's where all this comes from. But anyway, getting a bit sidetracked. So tan 30, sine 30 over cos 30. So again, work out what individual sine of cos 30 is. We did see sine 30 is a half. That's going to be a half over root 30, cos 30, which is root 3 over 2. Now these 2's will cancel, so you're left with 1 over root 3. Now actually you can simplify this by rationalising the denominator. If you times by root 3 over root 3, you get root 3 over 3, and that is tan 30. Okay, tan 45. That is sine 45 over cos 45. And so we know that sine 45 is root 2 over 2. And we know that cos 45 is root 2 over 2 as well. So actually, they're two the same. Divide by the same number, you just get 1. Okay. So tan 45 is 1. And then tan 60 is sine 60. over cos 60, which is, well, we've seen sine 60 is root 3 over 2. And over, we've seen that cos 60 is a half. So actually, the 2's cancel again. So you're left with root 3 over 1, which is just very simply root 3. And then tan 90 is sine 90 over cos 90. Sine 90 is 1 here, which we've shown, is 1. And now cos 90 is 0. And we're in a bit of trouble here. We're dividing by 0, so therefore it is undefined. And actually, this is what gives us this asymptote here. If you look at the tan graph, when it goes to 90x here, when it goes to 90, it obviously goes towards undefined. So that is the reason for this asymptote here, because we are dividing by this 0 here. Okay. So yeah, so those are all the values. I'm not going to write them all down now, like as a table, but that's how you derive it. I just want to do 1 or 2 examples of types of exam questions you'd get on it, and then we'll quickly move on to standard form. Do, do, do. Here we go. Okay. Okay. Let's do this one. So let's rejig our memory again. Let's do tan 60. Okay. So again, if you want, you can draw your hand again. 1, 2, 4, 5. A very weird hand. Anyway, let's label it 0, 30, 45, 60, 90. Okay, so tan 60, we should know divide sine by the cos. Now sine 60, remember start at 0 this way. So to get to 60, move 1, 2, 3 fingers, and that's over 2. Always over 2 is sine and cos, remember. And cos 60, again, we start the other way, so at 90. And then you move 1 finger there, so root 1 over 2. The 2's cancel. So you're left with root 3 over root 1. Root 1 is just 1, so you're just left with root 3. So the final answer is root 3 for tan 60. Okay, and that's how you can quickly derive any exact values. Okay, and just one last one I want to show. There's another one on here. It's when they start mixing it with triangles. Let's do this one here. Calculate length AB. Let's do it on here. No, I can't do it on here, can I? No, it won't let me. Let's just draw the triangle then. So the triangle looks like this. Very wonky. 60 and what's it, 12 centimeters? Yes, and it says to find AB. Okay. So it says to find X here, essentially. So, Trig, Sokotoa, right? So, Sokotoa. Uh, okay, so this is the hypotenuse H, and this is going to be the adjacent. So we're going to need to use cat, aren't we? So cos 60 is going to be x the adjacent over hypotenuse 12. Therefore, x is going to be 12 cos 60. Now, cos 60, obviously, is one of the exact values you need to know. So again, you can go back to the again draw a hand if you want to, very quickly. I'll draw 6 there, didn't I? There we go. Again, later, oh, it looks like a tree. 0, 30, 45, 60, 90. So, cos 60. So again, you root the finger over 2. So over 2. Now, cos 60, start at 90 this way and work our way that way. So 60, remove one finger. So it's going to be root 1 over 2, which is just a half. So then actually, x is going to be 12 times a half, which is just going to be 6 centimeters. So that is the missing length, and that's how you can use exact trig values to work out missing sides and using trig. It'd be very unfortunate. It could be like 2, 3 marks, and it'd be very unfortunate to lose all the marks there just because you don't know your exact values. So yeah, that's just a run. That's how you're meant to work them out. That's just a tour to do that. A whistle stop tour. Now we're going to quickly just finish on standard form, which you kind of touched on before. So this is just for the purposes of non-calculator. So a standard form is essentially any number that looks like this: so a times 10 to the n, but n is a power, and a is a number between 1 and 9. So for example, 1.2 times 10 to the 6 is standard form. Uh, uh, 6.4 times 10 to the -3 standard form. Also negatives as well. So you could have negative 3.865 times 10 to the squared. Right, that's standard form. But the second you move away from that, so if you then say, well, 15 times 10 to the 6. No, because you've gone over 10. As long as if you reach 10 or more, it's no longer standard form. And the idea is it revolves around the fact if you have 350.87, you can move decimal points by powers of 10. So if you have 10 to the 2, you're moving the decimal point right by 2 because it's positive. Remember, positive is the right direction. It's like with translation with vectors. If you translate by vector 4, 3, 4 is positive because you move to the right by 4 units. It's like the same. Right is right direction. Right is right direct. Oh God, that sounds so dodgy out of context. So yeah, so you'd move that to 2 to so if you times by 10 to the 2, you're gonna have 350 35,087. Now, on the opposite side, if you times by 10 to the -2, you're going to move the decimal point back by 2 points. So it's going to be 3.5087 instead. And that's all it is, essentially. So it was good to remember, I guess, 10 to the 1 is simply 10. 10 cubed, so that's 1,000. Because you move 3 decimal points, there's 3 zeros. 1, 2, 3, I guess. So there's 3 zeros there. Obviously that comes from 10 times 10 times 10. So obviously adding a 0 each time. And on the opposite spectrum, 10 to the 1. That's just 0.1. So you're going backwards away. Oh, sorry. You're going backwards from 1. So instead of decimal point being here, you move it there. 10 to the minus 3. So you move 3 decimal points back. So start with 1, 1, 2, 3. And it goes in that pattern. So the number here indicates how many decimal points you move. So if it's left negative, right positive. So minus 3, move 3 decimal points back. If it's positive 3, you add 3 points or add 3 zeros. If it's minus 3, you add well, not necessarily you add 3 zeros, but obviously 1 0 is going to be before the decimal point. So yeah, that's the way to think about standard form. Okay, so for the purposes of non-calculator, um, there are some question types you need to be aware of. That they could ask in a non-calculator. Uh, where are we? Where is it? Exact values. No, exact form. Standard form. Sorry. Where is it? There it is. Lovely. There we are. Okay, so uh, um, let's do this question over here. Question 14. This could be easily a non-calculator question. And I think a lot of people expect this to just be a calculator, but they can very easily turn it into a non-calculator and then people freak out. Um, so that's 5 times 10 to the 3 times 6 times 10 to the 7. Okay, cool. With these type of questions, when you're adding times and multiplying, you want to group the numbers together, 5 over 6, 5 times 6, and the 10 powers separately. So 10 cubed times 10 to the 7. And there's something we can do here. So 5 times 6 is 30. Now, this 10 to the power, we can bring this as 1. If you remember this index law, which I believe everyone should know, I think. If we have a to the m times a to the n, so two different powers, right, of the same base, the 10. 10 times something times 10 times something else, you can add them together. So this is what we're going to do here. 10 3 plus 7 is simply 10. However, that is not an exact standard form, is it? Because this is not less than 10. So actually, we're going to need to knock off a power 10. Actually, no. 30 is 3 times 10, right? Um, so 3 times 10 times 10 to the 10. Remember, this is a hidden power of 1. So it's 3 times 10 to the 11 if we add them again. This is now an exact form. So this is your answer here. Okay. So that's how you do that sort of thing without a calculator. Times the, again, split it up essentially. So do the integers first, the normal numbers, and then times the powers, and then bring them together. Okay. Another example, I believe, it's the last question here. So let's read this together. So the distance between Earth and Mars is 78 million kilometers. The speed of light is this, kilometers per second. Calculate the time it takes for light to travel between Earth and Mars. So we got distance. So again, it's distance, speed, time. So remember this triangle. We even covered this in the past paper we did earlier. So distance, speed, time. So it's asking for the time taken, right? So time we don't know, but we know distance is what was it, 87 million or something like that? 78 million kilometers. Oh, oh God, million kilometers. And speed was 3 times 10 to the 5 kilometers per second. Okay, so times in second. We don't know time. We want to work it out, but time is going to be distance over speed. However, um, if speed, there are several ways to approach this. You could convert both of them into standard form. We'll do for both approaches. We'll see. So first of all, let's convert both into standard form. You might be tempted to. So 78 million. You're going to need to know the other way. That's going to be 78. So remember, 1 million is this with 6 zeros. 6 zeros is 78. So you could say distance is, and then you can convert that standard form. That'd be 7.8 times 10 to the. So how many decimal points? 1, 2, 3, 4, 5, 6, 7 over and a speed which is 3 times 10 to the 5. And then likewise with multiplying, because this is a division ultimately, isn't it? You could say 7.8 divided by 3 um, times by 7 to 7 divided by 10 to the 5. Now 7.8 divided by 3, again, it actually links back to the division we did earlier. 7.8 divided by 3, well, bring it as one fraction, so 78 divided by over 3, 7.8, yes. How do we get rid of the decimal? Well, you're going to want to times by 10, so move it to the right by 1. 78 over 30. Uh, you could try to simplify it, but let's recap our skills from last time. So 30, bring it outside the bus stop, 78. So 30 doesn't go into 7, so you have to consider 78 now. 30 goes into 78 twice, with a remainder of 18. So it's 18 and then an O. So how many 30s go to 180? 30, 60, 90, 120, 150, 108, exactly 6 times, right? 2.6. So actually this answer here is 2.6 times. Now this is now like opposite to adding two powers together, when you divide, so a to the n over a to the n, you subtract them. So this is going to be 2 to the oh, sorry, wrong way. This is going to be 10 to the 7 minus 5, which is going to be 2. And that is going to be your answer in seconds, obviously, because it's in time. If you then wanted to convert that as an actual whole number, again, move the decimal point right by 2, so 26, 260. Move the decimal point 2 times, okay? And that's how you'd approach a question like that without a calculator. That's a good recap of skills, that is actually. I quite like that question. Um, what I mean? It does look quite scary. It pulls a lot of skills together, like distance, speed, time. So index laws, maybe perhaps division with bus stop, but it's all the same. Like there's multiple stuff together, but all of it you've done before. All of it makes sense. I think all of it's in reach. Really, there's nothing too out there. I don't think we're doing here. It's all the topics we've been doing this stream, right? Bringing it all together. And yeah. I guess to wrap this up, I wanted to look at one last question, actually, one other type. So that's if you're multiplying or dividing and standard form. Uh, but the last type of question is actually when you add or subtract them, because they can ask you that as well. Um, let's have a look. Uh, what questions have we got here? See, look how they're all the same. Like either convert stuff to standard form or do multiplications or divisions of them. Um, Some of them, obviously, some of them you can just use a calculator, but they can make it as a non-calculated question if they make the numbers fair enough. So that's what you got standard guard for. I think a lot of people expect, oh, it's just going to be the calculator. It doesn't have to be. The numbers can be nice enough, and they expect you to work with that. Okay, there's not really a question on there. I'll make my own one up. Okay, so they could also expect you to add or subtract two standard form numbers together. So let's do 3.8 times 10 to the 6 minus 4.9 times 10 to the 4. They could expect this as well. Plus, sorry, let's do plus. Obviously, subtracting is the normal way, as you'd subtract whole numbers, and that's the whole idea. So the idea is we're going to when you add, convert it to an actual number, right? So this is how this is where you need to know how to convert it. 3.8 times 10 to the 6. Let's plug it in. So 3.8. So you're going to want to move 6 decimal points to the right. So it's going to look something like this. So, and then let's test it. So the decimal point was here. 1, 2, 3, 4, 5. So we need to add another 0. And that number in standard form. Do the same with this. Add, because we're adding. And so 49 times 10 to the 4. It's going to be somewhere there. 49. Move 4 points forward. Hang on. Let's align the numbers actually. 49000. So the decimal point was here. So 1, 2, 3, 4. Lovely jubbly. And that's the whole idea. If they ask you to add or subtract the number in non-calculator, convert it in, don't be freaked out, convert it into a whole number like this, and then do your usual addition. Obviously, there's going to be a lot more digits, but it's exactly the same process as normal addition. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 9, 9, 0 and 4, 9, 8, 3. And that's your result, right? 3, 8, oh, okay, cool. If they then ask you, obviously, to convert that back into standard form, just do it. Uh, so obviously you need to make sure it's between 1 and 10, so 3.849. So then how many decimal points are we moving from here backwards? So it's going to be 1, 2, 3, 4, 5, 6. Okay. Bearing in mind, if we're going back, then it's not negative. So only if we're moving it, how do I explain this? I'm going to leave it there. I'm not going to confuse you. Um, but the idea is to think about it. If you want to know what sign it is, if it's positive, if it's a positive 10 power, that means you're increasing the number by adding more zeros that way. If you're making it 10 to the minus 6, bear in mind that's like 0.00001. That's making the number smaller. But here, if we want to times this by 10 to the 6, you're going to make this 3 point something bigger, which makes sense here because this is a bigger number than that. So if you're ever struggling with the order, just think, sit down a little bit, think what we're trying to do, like is the number getting bigger or smaller? Obviously, negative makes the number smaller, and then positive makes it bigger. But anyway, that I'll probably cover some more of that at a later date as standard form, how to convert numbers. But I'm assuming you're already sort of confident with standard form. The whole idea with this session is to go over specifically non-calculator examples. That is the idea. And I think these are the topics that they're going to come up in non-calculator. I really do. And I therefore think it's wise before Thursday you really make sure you're prepared for it. Everything else, they can put it on any three papers. There's not really any more. I think I call these like the specific paper one topics, but everything else they can throw in any paper, which you just need to learn. So stuff like algebraic fraction solving, quadratic factorizing, they can be in any paper. So you just have to be prepared. But I think these are the specific things to look out for specifically for non-calculator. And yes, so hopefully that helps. If any questions, let me know. But yeah, I'm gonna leave that there for now. So yeah, see you next time.